Hello, good afternoon, everyone. So, in the last class, we have seen how the water content of a soil is determined using your own drying method. So, now we will see one more experiment. I am sharing the screen. I hope it is visible to you. Yeah, it is on the desktop. Find the remember 23. Maybe it is in the download section. Downloads. 23 KB serial 57. 23 KB serial 57. Okay. Sorry for the inconvenience. So this third experiment was over. So now we will see the fourth experiment. That is determination of specific gravity by what you can say pyknometer method. Now, so experiment number 4, determination of water content of solids by pyknometer method. So what is the aim of the experiment? The aim of this experiment is to determine the water content of soil solids by pyknometer method. So what are the specifications? This test is done as per IS 2720. Water content already definition we have seen, that is mass of water in air to the mass of same amount of water in mass of soil in air to the mass of same amount in water, that is known as where this is the water content. Now for specification, this test is done as per IS 2720 part 2 1973. This method is suitable for coarse grained soils from which the entrapped air can be easily removed. So the specification is which code is used for this particular experiment, IS 2720 part 2 1973. This method is suitable for coarse grained soils from which the entrapped air can easily be removed. So what are the equipments required? Pyconometer of 1000 ml capacity with a brass conical cap, balance accurate to 1 gram, glass rod and other accessories. So theory, so a pyconometer is a glass jar of about 1 liter capacity fitted with a brass conical cap by means of a screw type cover. The cap has a small hole of about 6 mm diameter at its apex. The cap has a small hole of about 6 mm diameter at its width. For many soils, the water content may be extremely important index used for establishing the relationship between the way a soil behaves and its properties. The consistency of a fine-grained soil largely depend on its water content. So the water content is used in expressing the three-phase system of air, water, and solids in a given volume of soil. So water content W of a soil mass is defined as ratio of mass of water in the voids to the mass of solid. So water content percentage is nothing but W2 minus W1 divided by W3 minus W1 into G minus 1 divided by G minus 1 into 100. So what are the equations? What are W1, W2, W3, W4? W1 is nothing but weight of empty pyconometer in grams. W2 is weight of pyconometer plus wet soil. W3 is weight of pyconometer plus dry soil. Number 4, weight of pyconometer plus water in gram. So procedure, clean and dry the pyconometer and weigh it. So it will be W1 in grams. So first step is you have to clean and dry the pyconometer and weigh it. That will be W1 gram. Next, select a mass of wet soil of about 300 gram and place the same in pyconometer and weigh it. Call it as W2 gram. So first step is you have to clean and dry the pyconometer and weigh it. That will be W1 gram. Next, select a mass of wet soil of about 300 gram and place the same in pyconometer and weigh it. That will be W2 gram. First step is you have to clean and dry the pyconometer. Empty weight of pyconometer is W1 gram. In the second step, what you have to do, you have to select a mass of wet soil of about 300 gram and place the same in the pyconometer and you have to weigh it. That will be W2 gram. Now what you have to do, fill the pycnometer with distilled water up to half its length and stir the mix with a glass rod. In the second step, what you have to do, you have to fill the pycnometer with distilled water up to half its length and stir the mix with a glass rod. Keep on adding more water till the mix is flush with the hole in the conical cap. Dry the pycnometer outside and find the mass W3 gram. So W1 is empty weight of pycnometer, W2 is 300 gram of wet soil plus pycnometer. W3 is pycnometer with water and with soil. Finally, in the fourth step, what you are doing, remove the contents of the pycnometer and clean it. Fill it clean with water up to the level of the hole in the capper. W4. Weight of water in the pycnometer is your W4. Now use the above equation to determine the water content where G value is taken from experiment 1. That is determination of spectrography or pycnometer. So, what are the pre-bio questions? A pactometer is used to determine specific gravity as well as water content of soil. Other than pactometer, is there any to determine water content? Yes. Density bottle method is there, overriding method is there. So, other different methods are available. Which method is more accurate to determine water content? Oven drying method or pactometer? So, oven drying method is more accurate, I say. If there are lots of clouds in the soil, what will happen to the result? We will get an inaccurate results. Is it advisable to have lots of organic material? No. Explain the procedure to determine water content using pycnometer. So the procedure is simple. Weight of empty pycnometer W1 with lid. Next W2 300 gram of soil, wet soil. After that you have to fill with it water. That will be W3 dry soil. Finally you have to remove entirely everything and fill with water. That will be W4. So if you see the what you can say tabular column. Weight of empty pycnometer W1 gram. Weight of pycnometer plus wet soil W2 gram. Weight of pycnometer plus soil plus water W3 gram. So the weight of pycnometer plus water is W4 gram. So the water content W is given in this way. Average water content is W. So specimen calculation, how you will calculate water content? W2 minus W1 divided by W3 minus W1 into G minus 1 means G minus 1 into 100. So the average water content comes up to be W equal to W1 plus W2 by W3 divided by 3. So the result is average water content W is equal to percentage. So verification or validation, how you are determining soil mass is generally a three-phase system. It consists of solid particles, liquid and gas. The phase system may be expressed in SI units either in terms of mass volume or weight volume relationship. Water content value is 0% for dry cell and its magnitude can exceed 100%. So what is the conclusion? The conclusion is pycnometer method is the simple method to determine the water content of a soil. Experiment is carried out using the soil specimen collected from the college itself. All foreign matters are removed, clods broken, and water content we get from the soil specimen only. So comparing with the oven drying method, the value is this much. So what are the post bio question? Draw the schematic diagram of three-phase system based on the result. Is there any possibility of error by this method? In this case, what needs to be done? So there is a possibility of error. Which method gives the water content value rapidly? Pycnometer method or oven drying method? Pycnometer method gives is early value. So this completes our experiment number 4. So experiment number 5 is determination of in-situ density of soil by pore cutter methods. So it is a very interesting type of experiment. We will see it. To determine the field density or unit weight of soil by pore cutter method. So what is field density? Field density is used in calculating the stress in the soil due to its overburden pressure. It is needed in estimating the bearing capacity of soil foundation system, settlement of footing, earth pressure behind the retaining walls and embankment, stability of natural slopes, dams, embankment, and cuts is checked with the help of density of soil. It is the density that controls the field compaction soil. So what is field density? Field density is used in calculating the stresses in a soil due to its overburden pressure. So why field density is used? It is used in calculating the stresses in the soil due to its overburden pressure. It is needed in estimating the bearing capacity of soil foundation system of footing, earth pressure behind the retaining walls and embankment. The stability of natural slopes, the embankment and cuts is checked with the help of density of soil. It is the density that controls the field compaction of soil. Permeability of soil depends upon its density. So relative density of soil is determined by knowing the dry density of soil in loosest and densest state. Void's ratio for acid and degree of saturation need the help of density of soil. So what is the specification? This test is done to determine the in situ dry density of soil by pore cutter method as per IS 2720 part 29 1975. So how this test is performed using core cutter method as per the IS code 2720 part 29 1975. So core cutter method in particular is suitable for soft to medium cohesive soil in which the cutter can be driven. It is not possible to drive the cutter into hard and boulder soils. So what are the equipments required? Cylindrical core cutter, 100 mm internal dia and 130 mm long. Steel dolly, 25 mm high and 100 mm internal diameter. Steel rammer, mass 9 kg. Overall length is to calculate this one. So sorry for the inconvenience. Where did we stop? Equipments required. So what are the equipments required? Cylindrical core cutter, 100 mm internal diameter and 130 mm long. So cylindrical core cutter you have to take and its dimension is internal 100 mm internal diameter is there and its length is 130 mm long. Steel dolly, 25 mm height and 100 mm internal diameter. So what about steel dolly? Its height is 25 mm and internal diameter is 100 mm. Steel rammer of mass 9 kg, overall length with the foot and the staff of about 900 mm. So what is the weight of the steel rammer? 9 kg and overall length with the foot and the staff is about 900 mm. Balance with an accuracy of 1 gram. Pellet knife, straight edge steel, etc. Square metal tray 300 into 300 into 40. And finally, trowel. So theory, field density is defined as weight per unit volume of soil mass in the field at in situ condition. In the spot adjacent to that where the field density and the soil mass has been determined or planned, drive the core cutter using the dolly over the core cutter. Stop ramming when the dolly just brought surface, take out the cutter containing. So it is in a way procedure only. First, what you have to do? Field density definition. What is field density? It is defined as weight per unit volume of soil mass in the field at density condition. In the spot adjacent to that where the field density by sand replacement can be determined plan. First, what you have to do, you have to drive the core cutter using the dolly over the core cutter. After that, what you have to do, stop ramming when the dolly is just brought to the surface. Dig out the cutter containing the soil load of the ground and trim off any solid excluding from sand so that the cutter contains a volume of soil equals to its internal volume, which is determined from the dimension of the cutter. The weight of the contained soil is found and its moisture content determined. So what is the equation used? Rho d is equal to rho t divided by 1 plus W gram per centimeter cube, or rho d is equal to gamma d is equal to gamma t divided by 1 plus W kilonewton per meter cube. So rho d is dry density in gram per centimeter cube, gamma d is dry density weight in gram per centimeter cube, rho t is field moisture density in gram per centimeter cube, gamma t field moist unit weight in gram per centimeter cube, W water content percentage, gamma W unit weight of water 9.81 kilonewton per meter cube. So what are the precautions you need to take? Core cutter method of determining the field density of soil is only suitable for fine grained soil, that is silts and clay. So core cutter method is suitable for only fine grained soil, for example, silts and clay. That is, core cutter should not be used for gravel, bulldozer, or any hard surface. Why? This is because collection of undisturbed soil sample for recognition is difficult, hence the field properties, including unit weight, cannot be maintained in a core sample. Core cutter should be driven into the ground till the steel dolly penetrates into the ground halfway only so as to avoid compaction of the soil in the core. Before lifting the core cutter, soil around the cutter should be removed to minimize the disturbance. While lifting the cutter, no soil should be dropped down. So what is the procedure? These were the precautions. Now we will see procedure. First is measure the height and internal diameter of the core cutter to the nearest 0.25 mm. First step is you have to measure the height and internal diameter of the core cutter to the nearest 0.25 mm. Next is you have to calculate the internal volume of the core cutter VC in centimeter cube. First, measure the height and internal diameter of the core cutter to the nearest 0.25 mm. Next, calculate the internal volume of the core cutter VC in centimeter cube. Next, determine the weight of clean cutter accurate to 1 gram. That will be W 1 gram. Select the area in the field where the density is required to be found. Clean and level the ground where the density is to be determined. Place the dolly over the top of the core cutter and press the core cutter into the soil using the rammer. Stop the pressing when about 15 mm of the dolly pockets over the soil surface. In the next step, what you have to do, remove the soil surrounding the core cutter by digging using spade up to the bottom level of the cutter. Lift lift up the cutter and remove the dolly and trim both sides of the cutter with knife and straight edge. Clean the outside surface of the cutter and determine the mass of the cutter with the soil W2 in gram. Remove the soil core from the cutter and take the representative sample in the water content containers to determine the moisture content. The field test may be repeated at other places if required. So the water content of sample collected is determined in the laboratory as per experiment number 3. That is determination of water content by soil cell. To use the above equation given the theory section for determining the density of soil, gamma D or rho D. So what are the pre-viva question? Out of wet density, dry density and saturated density, which one of them is maximum and minimum? Explain. See here, this value may vary. You cannot say that dry density will be always maximum or wet density will be always minimum. Depending upon the soil properties, it may vary. What are the main factors which affect density of soil? So the factors affecting density of soil is mass of soil, volume of soil, type of soil. Beside the density, what other properties do you calculate? The voice ratio, degree of saturation of soil. Degree of saturation and voids also can be calculated using the empirical equations, which is the most accurate to determine field density. So it has to be C. So what are the observation? Length of core cutter, diameter of core cutter, volume of core cutter. So these are the observation. Now, tabular column consists of weight of empty cutter W 1 gram, weight of cutter plus wet soil that will be W 2 gram, weight of core cutter, volume of core cutter WC centimeter cube. Weight of empty container. Weight as of empty container W 3 gram. Weight of container plus wet soil W 4 gram. Weight of container plus dry soil W 5 gram. Water content W is equal to W 4 minus W 5 divided by W 5 minus W 3. Field moisture density root in kilonewton per square. W 2 minus W 1 divided by VC. Dry density rho d in kilonewton per equal to rho d divided by 1 plus W. So average density is average density. Specimen calculation. Average rho d is equal to rho d1 plus rho d2 plus rho d3 by 3. Average density field density. The dry density of moisture varies from the range is 1.1 to 1.6 gram per centimeter. In sandy soils, dry density can be as high as 1.6 gram per centimeter. In cloy soils and aggregate loams, it can be as low as 1.1 gram per centimeter. So what are the conclusions? The value of dry density of soil is this much. The type of soil is this much. Post Viva question. Can we use core cutter method on stony or non-cohesive soils? No. Which method is more accurate, sand replacement or core cutter method? Sand replacement, we have not studied. So we cannot make a comment on it. What is the practical application of the current data? Practical application is that we will be able to identify what exactly you mean by field density, wet density, that we will know. Do we get undisturbed sample using core cutter? No. Only disturbed samples are calculated using core cutter. Why is field density required? Field density is required because it is a very important parameter in order to know the wet cell and degree of saturation. Out of wet density, dry density, saturation, and the maximum minimum. So this is again a difficult question. It may be a maximum minimum depending upon the values. So next experiment is determination of in-situ density of sand. In-situ density of sand replacement. Determination of in-situ density by sand replacement method. Just now we have seen core cutter method. So now we will see in-situ density by sand replacement method. So the aim of the experiment is to determine the in-situ density of natural or compacted soil using sand replacement method. The in-situ density of soil, natural soil is needed for determination of bearing capacity of soil for the purpose of stability analysis of soil, for the determination of pressure on underlying strata, for the calculation of settlement and the design of underground structure. Moreover, dry density values are relevant both of embankment design as well as pavement design. So what it is saying, the in-situ density of natural soil, why it is needed? For determining bearing capacity of soil, for the purpose of stability analysis of slopes, for the determination of pressure on underlying strata, for the calculation of settlement and the design of underground structure. Moreover, what is happening, the dry density values are relevant both of embankment design as well as pavement design. Specification. The test is then to determine the in-situ dry density of soil by core cutter method as per IS 2720 Part 28 1975. In order to conduct the test, select uniformly graded clean sand passing through 600 micron ISA and retain on 300 micron ISA. So this test is done to determine the in-situ dry density of soil by core cutter method as per IS. What are the specification used? IS 2720 Part 20 1975. In order to conduct the test, select uniformly graded clean sand passing through 600 micron ISU and retain on 300 micron ISU. So these are the ISU used. Next, equipments required. So what are the equipment required? Sand pouring cylinder of about 3 liter capacity. A small pouring cylinder as per IS 2720 Part 28. So this IS code also you should remember. Sand pouring cylinder of about 3 liter capacity. What is the capacity of the sand pouring cylinder? 3 liter. Cylindrical calibrating container 10 centimeter in diameter and 15 centimeter depth. So cylindrical calibrating container also you should use 10 centimeter internal diameter and 15 centimeter. Glass plate trays containers for determining the water content. Next, tools for making a hole of 10 centimeter diameter and 15 centimeter deep. Knife and other accessories. Metal container to collect the excavated soil. Metal tray 300 square and 400 weight, the whole of 100 mm diameter at the center. So this metal tray 300 square metal tray have to take 40 deep with a hole of 100 diameter at the center. Weighing balance, moisture content cans, glass plate about 450 by 600 square and 10 thick, oven and desiccators. So theory, by conducting this test, it is possible to determine the field density of soil. So what is the purpose of you performing this test? You'll be able to determine the field density of soil. The moisture content is likely to vary from time and hence field density also. So it is required to report the result in terms of dry density. In sand replacement method, a small cylindrical pit is excavated and the weight of the soil excavated from the pit is measured. Sand whose density is known is filled into the pit. By measuring the weight of sand required to fill the pit and knowing the density, the volume of pit is calculated. So it is somewhat interesting. You are digging something, you are making a pit, and you are filling that pit with the sand. Again, you are calculating its weight. From that, you are calculating the volume of it. It is very interesting. Knowing the weight of soil rotated from the pit and the volume of pit, the density of the soil is calculated. Therefore, in this experiment, there are two stages, namely calibration of sand density, measurement of soil density. The test is divided into two parts. Field density is defined as weight per unit volume of soil mass in the field at the in situ condition. Equations are rho is equal to rho t 1 plus w gram per centimeter cube, or rho is equal to rho t 1 plus w into kilometer per meter cube, where rho d is equal to dry density, gamma d is equal to dry unit weight, sigma t is equal to field moisture density, gamma t is equal to field moist unit weight, w is equal to water content, and gamma w is equal to unit weight of water equal to 9.81 kilometer per cube. The basic equation determining density using the sand replacement method is VH equal to WS divided by G into gamma W. Now rho T is equal to M divided by VH. So your rho D is equal to rho T into divided by 1 plus W, where VH is equal to volume of hole made in the hole, W is the weight of the sand that fills the hole, W is the weight of moisture removed from the hole, W is moisture content of soil removed from the hole, rho T dry density of soil, G is specific gravity of the solids, rho W density of water. Precautions. So what are the precautions you have to take while performing this test? If for any reason it is necessary to excavate the pit to a depth other than 12 centimeter, the standard calibrating can should be replaced by one with an internal height same as the depth of pit to be made in the car. Care should be taken excavating pit so that it will not result by leaving as this will cause problems, as this will result in lower density being recorded. No loose material should be left in the pit. There should be no vibration during this test. It should not be forgotten to remove the tray before placing the SPC over the pit. Stage 1, determination of mass of sand that fills the cone. Number 1, measure the internal diameter D and height h of the calibrating can and compute its internal volume. So V is equal to pi d square into h by 4. With the valve closed, fill the cylinder with sand. The weight of sand filled in the cylinder plus cylinder is equal to W s grams. Keep the cylinder on glass plate which is kept on a horizontal surface. Open the valve and allow the sand to fill the cone completely. Close the valve. Weight of sand in the cylinder plus cylinder equal to W grams. Determine the mass of the sand left in the cylinder. Weight of sand which fills the conical portion W1 is equal to W dash minus W double dash. The difference between the mass of sand taken prior to opening of the valve and the weight of sand left in the sand after opening the valve gives the weight of sand that fills the pot. Let the mass be W1. Determination of bulk density of sand. So how you determine bulk density of sand? Measure the internal dimensions of the calibrating container and find its volume. Length of calibrating container is given by L centimeter, diameter of calibrating container D centimeter, volume of calibrating container is equal to centimeter cube. So second step, we place the pouring cylinder eccentrically on the top of the calibrating container with the valve closed. Find the cylinder, fill the cylinder with sand up to about 1 centimeter below the top. The weight of cylinder W1 grams. Weight of cylinder plus sand in the cylinder is W2 grams. Weight of sand filled in the cylinder W naught equal to W2 minus W naught. Let the weight of sand be will be W naught. Open the valve of the cylinder and allow the sand to flow into the container. When no further movement is sand is seen, close the valve. Find the weight of the sand left in the cylinder. So the weight of the cylinder plus sand after filling the container is W3 now. Determine the weight of the sand that fills the cylinder in the container W is equal to W2 minus W3. The bulk density of sand progress is given by WC by VC. Determination of density. Leave the area where the density is required. Place the metal plate on surface which is having a circular hole of about 10 centimeter diameter center. Dig a hole of diameter up to 15 centimeter. Collect the excavated in the container. Let the weight of the soil remove less W2 grams. Remove the plate and place the sand pooling cylinder eccentrically on the hole. Fill the cylinder with sand up to a constant level with a shutter valve closed. Open the valve and allow the sand to run into the till no movement of sand is observed. And close the valve and determine the mass of sand that is in the cylinder. So the weight of cylinder plus sand after filling the hole complete is W4 gram. Weight of sand filling only the hole in the fill is W is equal to W2 minus W2 minus WC. Volume of hole VH equal to WS by OS, where OS is the bulk density of sand. The bulk density of sand is rho T equal to W by VH, W by WS into rho S. So determination of water content is left that we will see in the next class.